This is Lauren Peterson, and my project is about mind-controlled robotic prosthesis. In September 2013, the New England Journal of Medicine released a study about a robotic leg prosthesis that is controlled by brainwaves. Lee Hargrove, PhD, and a team of researchers at the Rehabilitation Institute of Chicago developed a system to use neural signals to safely control a bionic leg. Zach Vaughter lost his lower leg in a motorcycle accident 6 years ago. After being in a prosthetic leg, he is the first to test the thought-controlled bionic leg. The device, which weighs approximately 10 pounds, pushes him up and down stairs, and the movement is seamless. After an amputation, the muscles are no longer there, but the nerve impulses are. Zach underwent surgery to move 2 nerves to his hamstring muscles. The nerve signals communicate with the sensor inside the limb socket, and the message is relayed to an onboard computer which instructs the knees and ankles on how to move. Photographs show an anterior view of the patient's residual limb with superimposed maps of electromyographic EMG signal amplitude corresponding to various movements. Areas of high EMG activity corresponding to strong muscular contractions are red. Areas with little EMG activity are blue. The last 2 panels show that the patient completed motions faster than did non-TMR transfemoral amputees. Developing a mind-controlled bionic leg is more difficult than a similar arm because the motors need to be powerful enough but still relatively small to give someone the energy to stand and move along, Dr. Levi Hargrove told NBC News. Zach Vaughter climbs 103 flights of stairs to the top of Chicago's Willis Tower, becoming the first person ever to complete the task wearing a mind-controlled prosthetic limb on November 4, 2012. Funded by an $8 million grant from the U.S. Army's Telemedicine and Advanced Technology Research Center, the researchers, in collaboration from Vanderbilt University, the Massachusetts Institute of Technology, the University of Rhode Island, and the University of New Brunswick, plan to develop the technology further. The device could help 1,200 soldiers and 1 million Americans with lower leg amputations regain their independence. On May 20, 2015, Össur, an Icelandic orthopedics company, unveiled the first commercially available mind-controlled bionic leg. What differentiates their smart limb is its simplicity. The sensors do not have to be attached to specific nerves, and the movements are based on myoelectric sensors which are implanted in muscle tissue. This concludes my presentation, and this is my list of references.